solving quadratic inequality. So we'll try to take a quadratic inequality expression and then try to find the solutions for x. So we will actually be learning a concept how to actually evaluate quadratic inequalities. So let us take an example for this. We will take something like x square minus 5x plus 6 greater than 0. So the first step would be to evaluate this into its factors. So we will factorize this expression as minus 3 and minus 2. So we have minus 3x minus 2x plus 6 greater than 0. So when we factor this one, we get x minus 3 minus 2 into x minus 3 greater than 0. So this can be written as two factors as x minus 2 and x minus 3 greater than 0. So now the step of trying to find the values comes where we actually will do like a product. That means when we have a product of two numbers and if it is greater than 0, which means positive, that means that either both the numbers will be positive or both the numbers will be negative, because multiplying two positive numbers or two negative numbers yields a positive quantity. So which means that we can actually write something like this: when x minus 2 and x minus 3 are two quantities, we can say if both are negative or both are positive, we can find the solutions. So we will end up with two cases. We need to solve these inequalities where when x minus 2 is we'll take the first case where both are negative. So when both are negative, x minus 2 is less than 0 and x minus 3 is less than 0. So when both are negative, we will get a positive quantity. So we will be solving this pair of inequalities. The second one will be when both are positive. So we will say x minus 2 is greater than 0 and x minus 3 is greater than 0. So solving the first pair, we will get x less than 2 and x less than 3. That means we need to find a common solution for both the inequalities that satisfies. So which means let us try to draw a number line. So if we take the numbers 2 and 3, the inequalities say that anything less than 2 is a solution for the first one, anything less than 3 is a solution. So that means what it means is that x less than 2 will be a solution for the both the inequalities, because the common solution is x less than 2. So let us circle the inequality as an answer. So that means x less than 2 satisfies the first pair of inequalities. For the second one, we say x greater than 2 and x greater than 3. So for this pair, when we again try to draw the two inequalities on number line, we get x greater than 2 and x greater than 3 as to the right hand side of the numbers. So the common solution for both will be x greater than 3, because you can see that x greater than 3 satisfies both the inequalities. So we say the solution set for this inequality in total is whenever x is either less than 2, or x is greater than 3. That means whenever x is less than 2 and x is greater than 3, these are all the solutions of x for this quadratic inequality. Let us actually try to plot it once so that we can actually get a feel of how or which regions of values of x are the solutions. So we'll try to use a xy plane here, and let us mark 2 and 3 on here. So we want all the values for x when x is less than 2. So x is less than 2 is a line. This line represents x equal to 2. So anything to the left of 2 will be the solutions for x less than 2. Similarly, when we take x greater than 3, let us try to draw the line x equal to 3, the dotted line, and then all the solutions to the right of 3 are the solutions. So which means that the solution for this inequality is all the values in this shaded region shown here. And we actually did this algebraically. So we don't have to really plot and see, but we are just going to get a feel of what are all the values of x that satisfy So the most important concept is when solving algebraically, you have to take them as a pair of factors and then go from there to find the solutions that satisfy the inequalities. We will take one more example to actually solve so that we get a good hang of how to solve uh, inequality expressions in quadratic expressions. So let us take inequality t square minus 13t less than equal to minus 40. So we will convert this into ax square plus bx plus c expression by taking everything on the left side. So this becomes minus 13t plus 40 is less than equal to 0. Now again we will factor this one. 40 has a factors of 8 and 5 that satisfy for 13. So we will write them like minus 8t minus 5t plus 40 is less than equal to 0. So taking all the things that are possible to take common, we get t into t minus 8 and minus 5 into t minus 8 is less than 0. So the factors are t minus 5 and t minus 8 less than equal to 0 are the factors. So now we need to find the solutions for these two factors. So because we are asking for less than, which means a negative number or equal to 0, what we do is we again find all the conditions. That means if t minus 5 was a number and t minus 8 is another number, when t minus 5 is positive and t minus 8 is negative, the product will be negative. Similarly, if t minus 5 is negative and t minus 8 is positive, that also yields a negative. So that means we need to solve for this pair of inequalities. So we can now write from the first one, for the first case is when t minus 5 is positive means t minus 5 is greater than 0 and t minus 8 should be less than 0 to or we can actually write them with equality because it has a equal to sign. Similarly, the second condition will be when t minus 5 is less than 0, less than equal to 0 and t minus 8 is greater than equal to 0. So these are the two pairs of inequalities we need to solve to find all the values of t satisfying this inequality. So let us take the first case. So with t greater than equal to 5 and t less than equal to 8, let us see what it means. So if I have to draw the number line 5 and 8, t greater than equal to 5 is all the numbers to the right of 5 and t less than equal to 8 is all the numbers to the left of 8. So the common solution for both is only the numbers that is shown here. That means from the dots as I pointed out, this is the range. That means between 5 and 8 is a common solution for both the inequalities. Therefore the solution will be t greater than equal to 5 and less than equal to 8. So the solution for the first pair will be t less than equal to 8. Oh, so we should be switching this one. So we should write this as t greater than equal to 5 and less than 8. So this is our solution. So let us circle the solution that we got for the first pair of inequalities. Now let us try to take the second pair. So in the second pair we have t minus 5 is less than equal to 0 means t will be less than equal to 5. T minus 8 greater than equal to 0 means t greater than equal to 8. So when we put them on a number line to see the solutions, we see that less than equal to 5 means everything to the right and greater than equal to 8 means everything to the left and t greater than equal to 8 means everything to the right. So we see that there is no intersection. That means there is no common set of solutions that satisfy both, which say that there are no solutions for the second pair of inequalities. So the only solution we get is the first, whatever we got from the first pair by solving the first pair. So we will say that the solutions for this inequality is t less than equal to 5 and t less than equal to 8 and t greater than equal to 5. So if I were to plot this on a xy plane and let t be the axis here instead of x, and then let us mark the numbers 5 and 8. So let us try to draw the lines t equal to 5 and t equal to 8. So these are the lines. So now which portion is t greater than 5? So definitely it is the inner portion. That means all this area that is shaded here represents the values of t that satisfies the inequality, this quadratic inequality. So this is how we actually solve a quadratic inequality. That means we first try to factor them, and then we try to convert them as a pair of factors, and then we actually see what is being asked. If it is a greater than 0, then the product of factors should be greater than 0, that means positive. And if it is asking for a less than 0, it means the product of factors should be negative, and therefore we will take the pair of inequalities that result from the factors. So in order to solve these kind of expressions, you should be very comfortable solving linear inequalities. That means with one variable inequalities, you should be very comfortable solving and then finding out the common set of solutions. And that's pretty much is the skill set required to solve a quadratic inequality. And we are actually drawing here graphically just to show which regions contains the solutions for this one. So it gives us a good feel that what kind of solutions we are getting when we draw them graphically.